Hello guys, today we are still on logarithmic equations and expressions, whereby we are going to do more examples into that. And kindly, before I start working on the examples, please support me by subscribing. You can comment, you can like, and you can share with your friends. Log of y base x is equals to 2 and xy is equals to 8. We are required to solve for the values of x and the value of y. So here we are going to apply all the rules that we learned of logarithms. And if you remember them, it will be easy for you to solve these examples. Otherwise, please go back and watch the other video that I did on introduction to logarithms, and also another video I did on logarithmic equations and expressions, the introductory part with some examples there. All right, so let's try to solve this. So as we can see, from these two, we should we should come up with simultaneous equations. And we also, earlier, I also showed you how to solve simultaneous equations, either by elimination or substitution method. If you haven't watched, kindly do so. Otherwise, I'm still going to leave the links in the description below so that you can watch. So from these two equations, we are going to form simultaneous equations. And from the simultaneous equations, you can choose. You will solve them using either elimination or substitution method, and you can work out for your values of x and y. But the way it looks like, we have to make it be in a position where we can solve it in either of those two ways. So we have to form now the simultaneous equations. And the second equation, that one looks okay. It's xy is equals to 8. That's fine. But from equation 1 here, we have to form an equation from there. And we have log we have log of y base x is equals to 2. We are going to form an equation from here, and as you remember, this one is in logarithmic notation, and we can transform it into index notation, whereby it's supposed to be x squared is equals to 2y. So we have our first equation there, and here we have our second equation. It's already there. And then now we are going to have the 2x squared is equals to y. We transformed, or we changed this one, the logarithmic notation, to index notation, which is this one. And this one, basically, we normally take the base, which is that one, and the index, which is this, which is the same as your power. So you'll have the base and the power something. So it's x power 2, then it's equals to y. So from there we got our first equation, and then now we have our second equation, which is xy is equals to 8. Now from these two, we can solve for the values of x and y. And we are going to solve them this way. We already know that y, we are going to solve by substitution. We already know that y is equals to x squared. So we can come to the second equation and substitute where we have y with x squared. So we are going to come here, x, then multiplied by the value of y is x squared is equals to 8. Okay, so we have x cubed is equals to 8. To solve for the value of x from here, we can decide either to find the cube root of both sides. That is option number 1. And option number 2 is to change this 8 into a base something, then power something. So the first way is to get the cube root and the cube root. The cube root of x cubed is x, and the other one is 2. Then the other option is to solve it this way. You have x cubed is equals to 8, x cubed is equals to 2 power 3. You have a base and then you have your index there. And therefore, you can cancel the 3 and 3 and you have x is equals to 2. Just the same way as getting the cube root of 8, the cube root of both sides. So now we have the value of x. Let's look for the value of y. We know that y is equals to x squared. And therefore our value of y should be y is equals to 2, which is the value of x squared. This is equals to 4. Therefore, we have now our two values, whereby x is equals to 2, while y is equals to 4. And you are done with example number 1. Let's look into example number 2. Example number 2, we have 2 log y is equals to log 2 plus log x, then 2 power y is equals to 4 power x. So just the same way as we've done for example number 1, we have to form simultaneous equations from these two. The first one looks okay, but from the first one we have to form an equation. And therefore, from the first one, let's first deal with the first one. Bearing in mind the rules that we learned on logarithms. So like for the first term, this one should be changed to, this one is the same as log y squared, and then the second one is fine, the other one is fine. So we are going to have log y squared is equals to log 2 plus log x. Are we together up to there? Then on the product rule, we apply the product rule there to get here is the same, is equals to log 2 multiplied by x when we apply the product rule. And therefore we have log of y squared is equals to log 2x. We can cancel the logs, and y squared is 2, the same as 2x. So we have our first equation like that, and our second equation was 2 power y is equals to 4 power x. Now we can solve these two. Okay? Alright. So we can still apply substitution method. So from the first one, let's get the value of y. When we have y squared is equals to 2x, what can we say is the value of y? For us to get y, we have to find the square root both sides, and therefore y is equals to root 2x. Then once we have it like that, now we come to the second equation and substitute where we have y with root 2x. So we'll have the second equation is 2 power y is equals to 4 power x, and y is root 2x. So we'll have 2 and then root 2x is equals to 4 power x. We have a base 2, we have a 4 there, so we have to change this 4 to a base 2, and changing it to a base 2, we'll have 2 root 2x is equals to 2 power 2. 2 power 2 is the same as 4, and then we have our x there. This 2 cancels with that one, and we'll have root 2x is equals to 2x. Let's get the squares of both sides, and therefore we are going to have 2x is equals to 4x squared. Okay, 2x is equals to 4x squared. 2x is equals to 4x squared. How can we get the value of x from here? We can divide by x first, and therefore here we'll have 2 is equals to 2x. 2 is equals to 4x. 2 is equals to 4x. So it's like we have 4x is equals to 2. Divide by 4, divide by 4, and our x is equals to 1 over 2. So we have the value of x, which is 1 over 2. Now we can get the value of, we have the value of x, which is the same as 1 over 2. We can get the value of y, and we said our y is equals to root 2x. And therefore our y should be equal to root 2 multiplied by x, which is 1 over 2. And y is equals to the square root of 1, which is equals to 1. Therefore our x is equals to half, while y is equals to 1. And you're done with example number 2. Let's look into example number 3. In example number 3, we have log of x plus y is equals to 0. And then 2 log x is equals to log of y plus 1. We have a log here, log something, and here we have a 0. So we have to change this 0 into a log something. Remember that log 1 is equals to 0. Log 1 is the same as 0. Therefore, this 0 is going to be replaced with log 1. So we are going to have log of x plus y is equals to log 1. And the second equation, we have log x squared. I hope you can see, you can understand why that one has become x squared. And therefore now, here that one can cancel with that, this one can cancel with this, and therefore we have our equations as x plus y is equals to 1 and x squared is equals to y plus 1. So we have those two equations. Then from the two equations, now we have to solve for the values of x and y. Okay? Alright, so let's have the equations here again. X plus y is equals to 1 and x squared is equals to y plus 1. Now let's solve the two equations. From equations 1, we can say that x is equals to 1 minus y, right? And then now we can come to equation 2 and substitute, where we have x with y minus 1. So this one means we have 1 minus y squared is equals to y plus 1. What is 1 minus y squared? Is the same as 1 minus 2y plus y squared is equals to y plus 1. Let's collect the like terms together. Y squared minus 2y minus y, is it? So, okay, 1 minus 2y plus y squared is equals to y plus 1. We collect the like terms together. Then we have this plus 1, and then we have a minus 1 is equals to 0. So we have y squared minus 3y is equals to 0. Y squared is equals to 3y, and our value of y is equals to what? We can divide by y, we can divide by y, and our value for y is equals to 3. And now, since y is equals to 3, what is the value of x? Y is equals to 3, and we know that x is equals to 1 minus y. So x is equals to 1 minus 3, which is the same as negative 2. Therefore, we have x is equals to minus 2, while y is equals to 3. And we are done with example number 3. Log of x squared minus 9 to base 3. This one is equals to 3 log of 2 plus 1 to base to base 3. So the first thing is to apply the power rule there, and we are going to have this looking like this way: 2 plus 1, then power 3. Okay, so now we can cancel the log 3 and log 3. Those ones can cancel out, and therefore we have x squared minus 9 is equals to 2 plus 1, then power 3. X squared minus 9 is equals to 3 power 3. X squared minus 9 is equals to 27. Okay, and therefore here we have x squared is equals to 27 plus 9. X squared is equals to 36. To get the value of x, we have to find the square root both sides, and therefore our value of x is equals to 6. The final example, example number 5, we have log y minus 1 plus 2 is equals to log of 3y plus 2 plus log 25. So for us, we can see everything is already in log. The only difference is here, but we have to introduce log here. We have to introduce log, and for us to introduce log, we have to make sure that since we have 2 here, then the log that we are supposed to introduce should be log something. We should be the same as 1, in such a way that when we multiply the value of that log with 2, we still get 2. And remember, we said log of a base a is equals to 1. So now our duty here is to check our equation is in log base what. If it's in log base 7, then it means we are going to introduce log 7 base 7. But as we can see, it's log base 10, right? So we are going to introduce the log 10. Base 10, this one is still the same as log, just log 10 is the same. Whether we have this 10 down there or not, it's still the same as that. So this is what we are going to introduce. And therefore we are going to have log of y minus 1 plus 2 log 10, right, is equals to log 3 plus 2 plus log 25. Okay, and then this one we are going to change it using the power rule, and it will become log 10 power 2. All right, so this is the same as log of y minus 1 plus log of 10 squared is equals to log of 3y plus 2 plus log of 25. Let's use the product rule because we have addition sign. Otherwise, if we had minus sign, then we could have used the quotient rule. So by using the product rule, we are going to have log of 10 squared is the same as 100, and then multiplied by y minus 1 is equals to log of 25 multiplied by 3y plus 2. Yeah, this log and this log can cancel out, and we can remove the brackets to have 100y minus 100 is equals to 75y plus 50. Let's collect the like terms together. 100y minus 75y is equals to 50 plus 100. This is the same as 25y is equals to 150. To get the value of y, we have to divide both sides by 25. And therefore our y is equals to 6. That's the end of our today's examples. Kindly subscribe to my channel, comment, like, and also share. Till next time, thanks, bye.